Hi everyone. My name is Shashank Guda, and I'm here to present my portfolio uh, on the project which I did. So, this is our agenda for today. We're going to go through the introduction, and I have chosen three uh, projects for my portfolio, and I'm going to give a brief about each project. So, a quick introduction about me. I'm Shashank Guda. I completed my master's in applied data science at Syracuse University. This is a program that emphasizes applying data science solutions to solve real world challenges across industries. And I took a diverse set of course covering areas like machine learning, big data analytics, cloud computing, database management, and human centered AI. Through these experiences, I developed skills in data engineering, machine learning, big data processing, AI application development, and statistical problem solving. Again, pursuing the MS in applied data science at Syracuse University has been a truly transformative experience for me. This program offered a rich blend of both technical blend as well as practical applications. And coming to the skills which I'm sort of experienced right now and jobs which I'm looking right now is in data engineering and database design, machine learning and model optimization, big data processing with Spark and cloud technologies such as Azure, AI application development with OpenAI APIs and vector databases, again with communication for both technical insights for business decision making. Overall, this program is not only strengthened my technical expertise but also helped me learn how to build practical impactful solutions by combining data, cloud technologies, and human centered design. Again, as I've said, I'm just going to choose three projects from my portfolio. First one is EqualEyes. This is my final project for IST 707 Applied Data Science. In this applied data science course, I led the development of EqualEyes project. It's At its core, it's an image caption generator designed to create detailed and accessible captions for visually impaired users and educators. Our team built and compared multiple deep learning models, including CNN, a Vision Transformer with GPT-2, and Blip, with Blip achieving the best performance. We trained on the COCO dataset, achieving a blue score of 0.72, and developed a web app that provides rich, descriptive, and accessible captions for images. Through this project, I strengthened my skills in machine learning, model selection, hyperparameter tuning, stakeholder driven design, as well as development of AI applications for social impact. So these are the methods which we sort of followed. We started by exploring the dataset through image size distribution, orientation checks, and assessing the sharpness of images. We also looked at caption lengths and word frequencies to better understand the data we were working with. So here, image size distribution is nothing but how the image is actually sized, whether the training data has this unique or same size for all the images, checking orientation of the image, quality again, whether the image is really sharp or whether it's blur, and what's the length of an average length of a caption, just to understand the number of words. And for word frequency analysis, we already performed like what are the most repetitive words which we were working with. Once we are done with our initial data analysis and exploration, we went on to pre-processing. Here we uh, detected any duplicate images present or not. So identifying and handling duplicate images in the data set using techniques like perceptual hashing. We did text tokenization and vectorization, converting text into numerical representations, also known as vectors for model training, and image augmentation, applying transformations such as rotation, flipping, etc., to artificially increase the diversity of training images. Once we are done with modeling, uh, once we are done with pre-processing, we moved on to modeling. Here we dealt with CNN encoder decoder, which is also known as Inception V3. This approach uses a convolutional neural network, CNN, like Inception V3, as the encoder to extract image features, which are then decoded by a language model to generate captions. We explored with another model, which is also known as Vision Transformer, VIT GPT-2. This model combines the Vision Transformer VIT for image encoding and the transformer-based language model like GPT-2 for caption generation, allowing for better capture for long-range dependencies. And we felt that our model can be still improved. So we've used BLIP, which is also known as bootstrapping language image pre-training. Blip is a unified vision language model pre-trained on a large data set of image caption pairs, enabling effective image understanding and caption generation through multimodal learning. So, and from this, we figured out that Blip is the model to go. So you can see this is a simple web app which we created based on our Blip model. You get the option to upload an image, and once you upload the image, you can click on generate description from file to get the description, accurate description of what the image is. And you can also choose we have added the feature of audio. So whatever description is generated, once you click on audio description, the model is able to speak this. So, for example, it would be sort of giving us the audio output of a crowd of people standing around the stage. And this is the image which we chose to upload. And again, this web app uses our Vision VIT GPT to generate descriptions and audio captions for user uploaded images. Before we moving on, Before we move on to our next project, I just want to highlight that uh, EqualEyes is such project which actually actively encourages us to contribute more to the society. I believe projects like EqualEyes can greatly contribute to making digital experiences more equitable, giving everyone, regardless of ability, a chance to interact meaningful with technology. And this EqualEyes actually taught me how to translate stakeholder needs to technical solutions, how to optimize deep learning models for real world deployment, and how important accessibility and inclusivity are in modern AI applications. Along with that, I learned how crucial it is not only to build accurate machine learning models, but also to think deeply about who we are building for. So that's what I learned from this project, and it's a really good project, at least for me. And moving on to our next project, which is anomaly detection in metro train air protection units. So this is my big data analytics ISA 78 final project. So in this project, we focus on building an anomaly detection system for metro train auxiliary power units. So here the data is basically from Portugal metro data. So we developed this anomaly detection system for metro train auxiliary power units to enable proactive maintenance and improve operational reliability. We processed 1.5 million rows sensor recordings using Apache Spark as well as Python. We applied k-means clustering and LSTM autoencoder models to identify abnormal patterns and predict high-risk periods. And we enhanced system safety by flagging these anomalies early and optimizing maintenance schedules. So that's just a quick overview. So this is our correlation matrix here. We started with our exploratory data analysis for our sensor data. And this is the correlation heat map of key sensors such as pressure readings, TP2, TP3, motor current, and oil temperature. One interesting insight was the strong correlation between TP2 and H1, meaning that one pressure increased that dropped sharply, and motor current also showed a strong relationship with oil temperature, indicating that load shifts can cause thermal stress, a critical signal for potential failure. So from EDA, we were able to figure out these insights. Next, we actually did a temporal analysis. You can see this is a temporal analysis. From this, we were actually able to see that the oil temperature is consistently high throughout the day, and fluctuations would likely indicate that system load changes or cooling inefficiencies. Other sensors exhibit flat or slightly fluctuating trends across 24-hour period. There weren't any distinct hour peaks or troughs, suggest that a system operates under a consistent workload without any pronounced time shifts. Moving on to next slide. So the methods which we used after the initial analysis, we used the combination of both statistical analysis and unsupervised machine learning techniques. We performed clustering using k-means to separate normal and abnormal operation states. We tested clusters from k equal to 2 to k equal to 8 and found that two clusters captured the behavior best. And we built a deep learning model using LSTM autoencoder, training it on time series sequences to capture subtle changes in behavior that clustering model might miss. So just a quick summary, we used both statistical analysis. So as we just saw, we were able to find out correlation analysis between sensors, digital sensor state monitoring and concurrent activation patterns, distribution analysis of sensor readings. And we also did unsupervised learning. Here we use k-means clustering as well as LSTM autoencoder analysis. So when we talk about cluster analysis, so you can see this is the chart which shows the clustering results based on the oil temperature. There are most operational states shown here are cluster 0, which were normal with oil temperatures between 50 to 70 degrees centigrade. However, cluster 1, which are represented in yellow dots, represent anomalous behavior with temperatures above 70 degrees, suggesting overheating and early warning signs of system stress. Moving on to our LSTM analysis. So to capture more complex patterns, we trained an LSTM autoencoder trained over 10 epochs. As you can see, both the training and validation loss decreased steadily, and they converged by 8th epoch, which showed that model was learning efficiently without overfitting. And when we talk about decreasing loss, both the training and validation loss are decreased consistently over the epoch. So again, this just highlights whatever I just said, that the model is actually learning accurately without overfitting. And moving on to our next slide, going on to LSTM reconstruction error. So after training, we analyzed the reconstruction error. Most of the normal data points had low reconstruction error between 0 and 1.5. We then set the anomaly detection threshold at a reconstruction error of 2. Points that crossed this threshold were flagged as anomalies or rare but highly important events indicating potential failures. So as you can see, the dotted red line is our anomaly threshold, which we kept it at 2. And beyond that, we can see all these dead points come under anomalous behavior. And we then made sure that our model had predicted few dates or outputs. We validated our system by comparing the model's flagged high-risk periods with actual historical failures. So excitingly, the model correctly identified risk spikes around May 29th and June 5th. I have highlighted that in a red box. So which aligned with recorded air leak failures in the metro systems. This validated that our system could offer early warning and enable proactive maintenance, reducing downtime and improving safety. Again, this is one such project where I was really happy and we were able to create a real-time impact. Through this project, I strengthened my skills in big data processing, especially using Apache Spark, time series modeling, and deep learning for anomaly detection. More importantly, I learned how to design more scalable solutions that make real world systems smarter, safer, and more reliable. Moving on to my third project, this is also one of the project which I'm really interested in, and I really want to sort of develop more on this because this is actually built on recent AI advancements, and this is a part of my IST 6888 course, building human-centric AI applications. So let's see what this project is about. So my quick overview about this project is we developed an AI-powered chatbot called Compass to help international students select US universities based on factors like cost of living, job market, and program strengths. We integrated OpenAI's ChatGPT models and ChromaDB for semantic search and Snowflake for scalable data storage. We implemented retrieval augmented generation RAG to deliver accurate and personalized university recommendations. We also focused on building a user-centric, scalable, and efficient AI solution for real-world educational guidance. So we might be thinking there will be a quick Google solution for this, or you can go to consultancies to get a recommendation list of universities. But why does our compass make sense? Why does our compass stands out? It's mostly due to our personalized experience. We retain user preference for tailored recommendations, unlike generic chatbots. We offer specialized guidance, focus on mostly international students, needs with precise university, job market, and cost insights. We have built-in tools. So we provide an application tracker and checklist templates, streamlining the process for students. We do provide real-time insights also, and we integrate weather and job data for actionable and location-specific advice. So what are the key insights I just discussed? So one major feature was long-term memory. We stored user preferences and chat histories using persistent storage and ChromaDB, which allowed for personalized and context-aware conversations across multiple sessions. We also designed the system following LangChain principles, where data retrieval, embeddings, and querying process were streamlined in modular steps, even though LangChain itself wasn't directly used. Finally, we conducted LLM evaluation based on accuracy, relevance, latency, and user experience, ensuring that the recommendations provided were not only correct, but also fast and highly personalized. So as I talked about how important personalization is, because you can't really give recommendations of same universities to multiple users. The universities should sort of cater to your own needs. So long-term memory and user preference storage are really crucial for delivering these kind of context-aware responses. Then again, we have multiple models. How did we fix on one model. So again, it's really important to balance accuracy, cost, and latency. Choosing the right LLM, which is in our case GPT-4o Mini, was pivotal to achieving balance between response, quality, speed, and affordability. What's the role of advanced tools? We integrated with ChromaDB because we needed one vector database to retrieve the files from. So ChromaDB did the job for us. It provided vital for efficiently managing and retrieval structured data, such as expenses and job market trends. Embedding techniques added semantic understanding to user queries, improving the relevance of responses. Again, we are focusing on making our application as user centric as possible. So features like preference matching and downloadable templates, which we have that in our application, address real world student needs, enhancing the platform's practicality and usability. So what are the key lessons learned from this project? What we felt that just creating a whole application as a whole was really difficult. You just start from basics. You just add one feature at a time and make sure your team is having the bandwidth to contribute to your application. So iterative development is key. Regular evaluation and testing with different LLMs and configurations ensured continuous improvement and alignment with user requirements. We need to always think about scalability too. Maybe someday it's going to really hit off, and it's going to be big. So you can't really stick with 10 to 15 users. You need to start thinking about 100, 150, 200 users. So you need to design a modular and API driven architecture. In this case, which we use embedding functions and ChromaDB. This actually prepared the system for future scalability and integration. Again, domain specific fine tuning is really important. Here, our main focus was to help international students to make sure their process of applying to masters is really easy and giving them the right information based on their personal choices. So domain specific fine tuning is really important. We do have general purpose LLMs; they perform really well, but having that personalization and incorporating domain specific data. In our case, we incorporated university information from hundreds of websites available on the internet, and we also incorporated the cost of living data. This significantly boosted relevance and user trust. So users who use our application can actually trust our application because we are actually giving them the relevant information and it's a truth information. Our model is not hallucinating. Finally, user feedback drives refinement. This is really important because continuous feedback from testing scenarios highlighted the importance of usability features such as checklist generation and application tracking. So the screen which you can see right now is our app UI. It's a login page. Here you can see you can enter your name. So this name is acts as a username. We went on authentication based system. So for example, I just entered my name here. So in future, if I enter the same name again, it's going to recover all the chats I have had with the chatbot. So make sure you enter the name. This is the first page. Once you enter your name, if you're a new user, you get to choose your own user preferences. In this case, I chose the field of study to be electronics. Budget can be anything, or if you have a set budget, you can choose your own budget. And locations also, you can keep any locations if you're for your preferred locations, or if you're okay, you can keep all locations. Same with weather. Weather is a really important factor, especially from someone coming from India. Weather really is an important factor in choosing university. So once you get all these preferences, you can just click on save preferences, and you can always change these preferences based on your need. And once you enter your preferences, you can see this is the page which you're going to work with. You can see all your information is on the left hand side, your preferences, your field of study, the budget, and whether you can always click on edit preferences to change these preferences. I have 4 quick, easy to use buttons. So if you don't know where to start, you can click on top 3 recommendations to, just get a quick overview based on your profile. So once you click on it, you'd be seeing 3 recommendations. You have your University of California, Berkeley, University of Michigan, and Georgia Institute of Technology. So this is how our chat box looks like. You do have a download checklist. So checklist is nothing but what are the important applications and documents would you be requiring to apply for a certain university. Just to stay on track of everything, you need to download the checklist. There's a tracker too. So for example, if you have any universities which you already applied or are in the process of applying, you can use this tracker template to make sure your everything is on one sheet and you get that opportunity to track the universities. So this is our simple UI. We build this UI using Streamlit again. One important, as I just want to conclude, these were my three projects. I main takeaways from this project was, how we were able to integrate multiple components. We've used Chat GPT, we have used OpenAI's LLMs, we used ChromaDB vector database, we used embeddings. All this stuff is actually quite separated, but they're going to do wonders if you sort of know how to integrate them together. So yeah, I think that's the end of my third project, and it's been an amazing experience for me here at Syracuse University, and I'm really excited to apply these skills in my future too. So thank you for giving me an opportunity to explain about these skills. Yeah.